Hello everyone. My name is Sanya Sayar. I'm a student of 4th SEM CSE studying in Sri Venkateswara College of Engineering. And today my topic is derangements. Nothing is in its right place. Let us know what are derangements. Derangements are special types of permutation where no element appears in its original position. The concept is often summarized with the phrase nothing is in its right place. Understanding derangements, applications in combinatories, cryptography, and problem solving. Here we have a diagrammatic representation where we can understand it in better permutation and combination. Let us look at the mathematical definition. A derangement is a set in the permutation where all the original items are displaced. The number of derangements of n items is denoted as factorial n or d of n. The formula to calculate derangements is given by d of n equals n factorial. Next, let us look at the examples of derangements. For a set of three items 1, 2, 3, the derangements are 2, 3, 1 and 3, 1, 2. For four items 1, 2, 3, 4, it includes 2, 1, 4, 3 and 3, 4, 1, 2. Each derangement is a unique arrangement where no item retains its original position. Here we have an example of permutation where we can understand. Next, we have the recursive approach. Derangements can also be calculated using a recursive formula, that is d of n equals n minus 1, and then d of n minus 1 plus d of n minus 2. This formula is derived from the understanding of the choices for the first term in a derangement. Here, let us look at the formulas. Nth term of an AP equals a of n is equals to a of n minus 1 plus d for n greater than or less than 2. Nth term of GP is a of n equals a of n minus 1 into r for n greater than 2. Next, we have Fibonacci sequence. A of n equals a of n is to 1 plus a n minus 2 for n greater than 2. Here, an is the nth term, d is the common difference, and r is the common ratio. Factorial and derangements. The number of derangements is closely related to factorials as derangements are a subset of permutations. The relationship can be expressed as d of n equals n factorial, where 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on. Moving on to applications in real life. Derangements can be used in secret Santa gift exchanges where no one receives their own gift. They also appear in scheduling problems where tasks must be assigned without repetition. In cryptography, derangements can also help create secure communication channels by scrambling data. Next, we have the inclusion-exclusion principle. The inclusion-exclusion principle provides a method to count derangements systematically. It involves calculating the number of total permutations and subtracting those with fixed points. This approach can be generalized to various combinatorial problems beyond derangements. Here we have an example where next we have connection to probability. Derangements have interesting applications and implications in probability such as hat-hat check problem. In this scenario, each person randomly receives a hat and the likelihood of no one getting their own hat is a derangement. The probability of a complete derangement for n item approaches 1 by e as n increases. Here, let us look at an example. Giving a test to a group of students, the grades and gender are summarized below. If one student was chosen at random, find the probability that the student got an A. Here we have the table, male, female, and the total number of students. P of A is equals to 30 divided by 68 since the total is 30 and 68, which is equal to 15 by 34. P of E equals favorable number of outcomes divided by total number of outcomes. Visualizing derangements. Visual aids can help in understanding derangements such as graphs or diagrams showing item positions. Animation can illustrate how items are rearranged into derangements. This visualization can enhance comprehension of the concept and its applications. To conclude my presentation, derangements are a fascinating area of study in combinatorial mathematics. They challenge our intuition about arrangements and placements. Understanding derangements open doors to various applications in mathematics and beyond. Thank you for watching.